Composites One Demo Zone. My name is Neil Smith. I'm one of the technical support managers for Composites One, covering the western region of North America. So we have with us the team. Let's go over here a little bit closer, guys. Come together. So we got Matthew Parmental from PRC. We got our Vectorply team. Raise your hands. We got our 3A team there. Polynt, the Doug, and Airex from MVP. So they can help us out with our demo today. So I wanted to start with a bit of an overview of where this demo basically came from. We collaborated with one of our customers called Modvans, who I think may be somewhere out in the audience somewhere. There he is. Raise his hands. Good. So if you want a van converted to transit van, yeah, then talk to the gentleman out there. So I worked with him to put together a composite battery box. So he was one of our customers from a couple of years ago, and they were doing a wooden battery box, and we thought it would be a great idea to work together to design and produce a tool to make a composite battery box. So battery box is actually over there on the table. It's assembled with all the battery cells. Watch a little video after our demo. So this is, of course, the part that we're making that is in the mold from yesterday. So this is the one we produced yesterday. This is the one that we produced the day before. As you can see, there's a little bit of flashing around the perimeter. Hey, James, can I give this to you so it doesn't fall over? Thank you. So a unique feature to this battery box, or to this part, is the what I'll call the jigsaw flange feature or detail around the flange. And so what it does is it allows for us to put the battery boxes together, because there'll be a series of battery boxes with the battery cells installed on the van floor to be able to put more battery cells in the vehicle. So we did this to conserve space. So this was obviously a fairly complex geometry to cut and trim, as we all know, producing a lot of dust, a lot of time and labor to cut and trim and sand the flange. So we approached PRC with Matthew Parmental over here to talk to help us out with what we refer to as tailored fiber placement, or TFP. And so Matthew's going to give us an overview of that. But what it essentially allowed us to do is to do a net shape preform all the way around the perimeter with this complex flange without having to do any sanding or cutting or trimming. So saved a lot of time and cleaner environment. So I wanted to leave this one in the mold just as an example, because it shows the flashing, and if you can see, basically the cleaning the flange was as simple as just chipping off and putting a razor blade to the side of the part. So we're going to take that one away so we can have an available mold to make our part with. And a lot of the flashing is in my mold. So on that note, let me hand it over to Matthew Parmental with PRC.
Hello, my name is Matthew Parmental. I'm with PRC Composites. We're a engineered composite manufacturing company in Southern California. We've been in business for 50 years. And I'm here to introduce some of our new technology that we've been developing over the past year, tailored fiber placement, or TFP preforms. When we were approached for this project, if you think about typical RTM or trying to do a process like this, typically we would pull the part and we'd have a trim fixture that would then have to go to machining and be routed out to create the part. So what we've done here is, with the TFP, is a few things. One, we're trying to reduce labor, we're trying to reduce waste, and also we're trying to have consistent quality. Our machines are basically like a 3D printer for fiber. Long table, multiple heads, printing the same thing over and over again. So the consistency and quality, you're getting the same thing out of the box every single time. So our design here was to create two preforms. So our backing material we have to stitch to something is just a 100 GSM Owens Corning continuous strand mat. And our fiber that we laid down, this preform is all made with one single fiber. It is an Owens Corning 2400 Tex SE 1200. We can also change that. The backing is a design variable, so we have the opportunity to stitch to just about anything. And the fiber, we can lay down glass, carbons, and toe pregs. We do an epoxy carbon toe preg preform also. For this design, we did 2 preforms. Each preform has 3 plies. In the flange, this allows us to do ply 1 and 3 as a continuous strand around the flange to maximize strength. And then the center ply we did as a plus 45 on one preform and a minus 45 on the second. And that will bring down the sidewall and lock into the Vectorply material. Again, call plate, we basically just tack it into the call plate. Once the layup's done, this drops on. We do the infusion, part pops out, do a little sanding, part's ready to go. So we're saving labor, we're saving time. Again, consistent quality. If you have any questions afterwards, we're in booth PP38. I'd love to talk to you about it. Thank you.
Wow, fantastic. Thanks for that overview. So next, I'm going to introduce you to Mike Ditzler from Vectorply. He's going to talk a little bit about the Vectorply materials, but before he starts giving an overview of the reinforcements that we're using, or the other reinforcements other than the TFP that we're using in our demo today, we're going to start loading the tool. So we're going to put in our Vectorply with the foam core. So James and Edison from Vectorply, my colleague James Jones is going to place in our PET foam core from 3A Baltec. And it's a nice system where we basically center the foam core on the Vectorply fiberglass, push it into the cavity, and centers itself with the same amount of glass all the way around. And on that note, I'm going to hand it off to Mike to talk about the Vectorply product.
Thank you, Neil. Again, my name is Mike Ditzler, sales manager with Vectorply Corporation. Vectorply manufactures a multitude of multi-axial, non-crimped, stitched reinforcements. Wow, it's a mouthful. Primarily E-glass materials, but also carbon fiber, aramid, and hybrids of all those fibers. As Neil mentioned, the material we're using today is our E-TLY 3600. This is a 0 plus minus 60 stitched fabric, 36 ounces per square yard, and it's fairly well balanced between all 3 of those axes. The 0 plus minus 60 architecture allows us to produce a quasi-isotropic laminate and gives us good longitudinal stiffness in the part as well as torsional rigidity for the battery tray. Love to talk about your closed and open mold applications. You can come see us at our booth at HH33. Thank you.
All right, thank you, Mike. Yeah, hand off the mic to microphone to 3A, and 3A is going to provide a quick overview of the PET foam core we're using for our demo today.
Hey guys, my name is Ryan Adair. I'm lab manager with 3A Core Materials in High Point, North Carolina. At Baltec, we offer a full line of core materials: PET, PVC, PEI, and balsa, along with a couple others. In this application, we chose to use what is a T90 110 with a GPS configuration. That grooved and perved configuration will allow the resin to travel side to side, top to bottom. This material also has a good flexibility, making it easy to load into the form into the molds. Has a very good fatigue response. The box will see a lot of fatigue from the vibrations of the battery while it's driving down the road. So the fatigue response is very important in this application. The material has a pretty good insulation, about a 3.5 R value per inch. For the insulation properties to keep the temperature stable. We offer a wide variety of different finishing options. This particular demo, we're using the GPS, so the core is grooved and perforated to assist with the resin flow. This core has excellent fire-resistant properties. It's a good thermal formable foam made here in the USA. If you guys have any questions about the foam itself, please get with your C1 reps. They can get with us, and we can go from there.
Yep.
Thank you.
All right, thank you. Hand off the mic if you could hold on for a second here. So what I'd like to do is, hey James, I hate to do this. Pull that top cap. You know what I want to do. So pull the top cap off and show the permeability in the core with what we refer to as GPS or groove perf finish. So if we could, they're perfect. There you go. See that crosshatch pattern is providing the grooves to flow our resin, and that's providing the only form of permeability through the part cavity. We actually don't have, we have a decent amount of permeability on the TFP because it's actually stitched onto a scrim with a pretty good amount of permeability, so it flows up into that preform pretty well. So also, if I could have James try and fold up, so the first layer of Vectorply went down on the tool side, then the core went down over that, and then we folded the first 45 down, if that makes sense. So there's two 45s on the TFP. The first 45 goes down, and then we put that top cap of Vectorply over the top, and then sandwiched it between both of the 45 TFP plies, if that makes sense. So now they're in the process of pushing the corners really well, pushing the reinforcement into the corners really well to make sure we don't have any fiber bridging or bag bridging, which can give us excess resin. It can race resin too much, and we won't get a very even flow of the resin into the part cavity. So now they're going to fold down that last 45 ply over the top of the Vectorply. And the nice thing is that when we put the silicone bag for our infusion, our reusable silicone swirl bag for the infusion, we're going to put that down, and it slides that last 45 down into the part cavity. So the Vectorply and the TFP really integrated really well with each other around the flange. So while these guys are finishing up the rest of the layup, I'm going to hand it over to Polynt to talk a little bit about the resin that we're going to be injecting into our silicone bag for the infusion. Doug?
Thanks, Neil. My name is Doug Copeland. I work with the technical service group for Polynt Composites. The resin we're using today is Polynt A6104. It's part of the flame retardant group of resins that Polynt has. It's a non-halogenated resin that can be used with and without filler. The resin was designed to meet Federal Transportation Docket 98 testing requirements. These testing requirements require smoke testing, flame testing, and smoke toxicity. It passed the requirements with ATH in the formulation. 20% ATH easily met these requirements, and it still keeps the viscosity low enough in this resin to infuse easily. We're injecting today at 1.75. At 1.5% MEKP9 or 9H, we get about a 20-minute gel time. So you want to design the gel time to give you enough time to fill the part, but then you want a snappy cure to get cycle time.
No, that's great. That all makes sense. Now, we went on the conservative side. What tends to happen is those of you that are used to infusion processes, in general composites processes, is, yeah, we can put the bag on now. Yeah, sounds good. So yeah, match the A side to the A side. But basically, it takes a couple of parts to dial in the gel times and dial in the amount of catalyst and such. On this one, it's a really small part. We went super conservative, so the gel time of this, as Doug mentioned, significantly longer than it needs to be. But with Polynt's help and United Initiator's help, we dial those gel times in so that you can, significantly increase your cycles and pull apart much faster. So right now we're kind of doing the critical part of making sure that we tuck the silicone bag into all the corners. And really important feature that Edison actually is showing right now. So show the V groove. So that's the vacuum manifold, or that kind of perforated area. And the V groove, how we seal this bag is, yeah, James is pulling it up there. So we seal it with kind of a angled, almost trapezoidal shape of solid silicone, and it pushes into the groove, and there's a vacuum channel below the groove, and the vacuum channel pulls that kind of wedge-shaped silicone profile in and creates a really, really robust seal. So the other aspect of this, as James is going to point out, is, there's a perforated section around the perimeter of the vacuum cavity. And so we're using these scrim strips that James is pointing out to communicate vacuum from the reinforcement in our part cavity to the vacuum manifold that's integrated into the edge of the reusable vacuum bag. So And we actually, in this case, one of the unique aspects of this design was that we bridged the vacuum supply from the V-groove to the vacuum manifold around the perimeter, so we could do a single vacuum supply into the bag. So you gotta be a little bit careful if you draw excess resin, because it may end up going into the V-groove. So depending on the type of process, cure times, and those kinds of things, we may wanna do a separate vacuum supply for the manifold versus the V-groove, if that makes sense. So now we are in the process of, so we have to do we'd have to do our important vacuum check. So really hope that my gauge has not been misplaced. Okay, great. So the vacuum gauge is somewhere. We're gonna run a vacuum check first. Okay, perfect. So we're gonna run a vacuum gauge. As most of you working with the infusion process know, the vacuum integrity is paramount with resin infusion. It gives you that difference in pressure to drive the resin into the reinforcement and into the part cavity. So we'll turn the vacuum on now. And again, that's gonna draw the V-groove seal, and then the V-groove seal is gonna communicate vacuum to our part cavity. So in a minute, James, yeah, so Edison was just tugging on it. So we're already sealed in the V-groove, and we're gonna wait for about another 30 seconds or a minute to draw down the reinforcement in the cavity. So I think our max vacuum on this is only about 27, so should be about 27 reading on the gauge. And most important, for those of you not as familiar with infusion, you can't rely on the gauge on the vacuum. If the vacuum line is open, you have to do what we refer to as a closed cavity vacuum drop. So we're gonna go over to our vacuum supply after we've pulled full vacuum, and we're gonna close our vacuum supply line off, and we're gonna do a closed cavity vacuum drop and see how fast that vacuum reduces, right? So right about now, Edison's gonna kink off our vacuum supply. Nope, right here, yep. Or he uses the valve on the catch pot, even better. and we're gonna see if that needle kind of drops down. But one of the beautiful things with reusable silicone bags is that they're very repeatable as far as vacuum levels. You're not so worried about pleats in the vacuum bag leaking, sort of miscellaneous, if the guy's not having a good day and doesn't do a good bag. So we're good. So we have good vacuum integrity. Typically with silicone bags, kind of similar to light RTM, you don't necessarily have to do leak checks all the time because, like I said, it is a pretty repeatable vacuum integrity. So now we're gonna pop that out. We're gonna have our injection line gonna come into where our supply line is, and it's going to communicate, our resin is gonna communicate to a vacuum feed line that's integrated into the silicone bag, if you'd noticed. So, and it's gonna run down that feed line really fast once we introduce resin from our MVP injection machine. So we're gonna start with getting our vacuum back, and typically we'll have another line that we do vacuum check without having to take the lines off. So Eric here with MVP is, would you like to say a word about the machine?
Yeah, hey everybody, my name's Eric Navarro with Magnum Venus Products. I'm the technical sales rep for all of Mexico. The system we're using here is the Innovator 2 MegaJect. As you can see, there's a control box here with a bunch of standard gauges and different signals for this system. This box was more or less designed for ease of use for the operator. As you can see, everything is labeled well. You have your injection button, recirculation, a stop button, emergency stop. There's a predetermined counter on here, so if you know how much resin you want to go into your part, then you can set this up so that it will stop automatically as soon as the part is done being injected. Aside from that, you have a catalyst overpressurization alarm just in case there's any kind of issues with the catalyst. If for whatever reason catalyst isn't flowing and it's clogged, this alarm will go off and the machine will shut off automatically. We also have a gel alarm which can be calibrated. There's a little timer on the inside of there that you can adjust. And with that, basically, you're going to adjust it to whatever your gel time allows for. If your gel time is going to be longer than 10 minutes, then you have plenty of time there to adjust. And after your gel alarm goes off, a whistle will go off, letting the operator know it's time to flush before the resin gels on you. Aside from that, there's also the MPG, which works very well with the silicone bag, but also with rigid molds. Basically, what you're doing here is controlling the amount of fluid pressure being fed into your parts. So it's there to help prevent basically inflating your silicone bag, or with your rigid molds, preventing it from separating because of too much pressure. But if you have any more questions about our mixing and metering equipment, you can come see us right behind you at our MVP booth. It's BB33. Thank you.
Thank you, Eric. Yeah, so with that, we're going to inject our part. So Edison, you can pop our clamp off, and we're going to be ready to go. So you're not going to see the resin right away because it's pretty clear through the bag, but it really only takes a couple of minutes to run through the 3A channels in the core. So we're trying to control the the amount of strokes, so we don't over pressurize. So you'll notice when you don't have a semi-rigid mold like a light RTM, you do stand a chance of ballooning the bag a little bit, which typically doesn't really matter very much, but you got to make sure that it settles down so that you ultimately use all the resin in the bag. So we're going to be, what, about 65 strokes?
Yeah, we're at 52 right now.
Okay. Ballooning the bag a little bit when you're using a silicone bag is really not too big of a deal, as long as you pull out all the excess resin at some point. Ballooning the bag with a nylon bag can be an issue with styrinated resin because it can actually degrade the sealant tape seal. So you got to be a little bit careful with excess resin when you're working with sealant tape and typical nylon bag infusion. So how many strokes are we so far?
65.
Oh, so we're there. We're witnessing in the breather strips that are communicating our vacuum to our part cavity. So I think that about does it. We've filled our cavity, and we've made a battery box. So thanks everybody for watching, and enjoy the rest of the show. Thank you.